Okay, students, I will start fifth unit today. That is memory organization. Memory organization. So it is having two parts. See, that is unit 5 is having two parts. The first part I am explaining, that is memory organization. Memory organization. In the first part of fifth unit, the first topic is memory hierarchy. Memory hierarchy. So before going to memory hierarchy, we have to know what is main memory, what is auxiliary memory. Okay, so what is main memory here? What is main memory? See, memory is required. Definitely, for a computer system, memory is required. It is a heart. Okay. So the main memory unit that communicates directly with the CPU is called main memory. Is called main memory. So the memory which communicate directly with the CPU means here the processor. Okay, the processor, between the processor and memory unit, we are having the direct communication. But what main memory will have? What a main memory will have? It will have the programs, it will have the programs and data that currently needed by the processor. Okay, so what main memory is having? It is having the programs and the data currently that is used by the processor or CPU. Okay, so what is auxiliary memory? What is auxiliary memory? So the devices that provide backup storage are called auxiliary memory. So to provide the backup storage, whatever our data, okay, we need sometimes we need the backup storage for that our data. Okay, so the devices that is used for this purpose are called auxiliary memory. For example, for this case is magnetic disk and magnetic tapes. So, why it is used? That means it is used for storing system programs or large data files and other backup information. Okay, and these are transferred to main memory when needed. Okay, so the auxiliary memory is also having system programs and data files and other backup information. Okay, and whenever the whenever processor asked that backup data or file uh, it is transferred to the main memory. Okay, it is transferred to the main memory. That means all this data will be transferred from auxiliary memory to main memory. Okay, see, what are magnetic disk and tapes? Can you tell me, anybody, what is magnetic disk and tapes? Can you tell some examples what you are using? Have you seen magnetic disk? Have you seen magnetic tapes? Anybody?
RAM.
Yes? No. Magnetic disk and magnetic tapes. See, magnetic disks are nothing but CD or DVD. Okay, na? Compact discs or what is DVD. These are called magnetic disc. Have you seen CDs and DVDs?
Yes,
Yes. Yes, those are called magnetic disc. And what are magnetic tapes? Have you seen magnetic tapes?
yes, sir.
Can you tell me example? Magnetic tapes. Can you tell one example of magnetic tapes? What you have seen? Yes, I'm sure. Okay. See, this is magnetic. Yes, have you seen this one? This is the floppy disk that is, we can call it as a magnetic tapes. Magnetic tapes. Okay, have you seen this one? Anybody? Have you seen? Yes or no? What is this actually? యూజ్ చేసినారండి ఇప్పుడు మీరు ఎవరైనా ఇందులో ఈ ఫ్లాపీ డిస్క్ ఎవరైనా యూజ్ చేసినారా? I think no.
Sir.
Have you seen, first of all, have you seen? Have you seen? Yes or no? Nowadays it is not available.
Yes, sir.
Have you seen at least physically? Have you seen? చూసినారా మీరు ఇది? చెప్పండి భార్గవ్.
Yes, sir.
చూసినారా?
Yes, sir.
ఎప్పుడు వాడినారు మీరు ఇది? Have you used this one? Pujita, have you used this one? Yes?
No, sir.
No. You have not used this one. If you are the students of around 2000 to 2004, definitely you have to use this floppy disk because at that time we are not having DVDs. Okay, only CDs are having. Okay, so to store permanently, to store temporarily data, at that time we are not having what is DVDs. To erase the data, actually nowadays we are having the pen drive. Okay, nowadays you are having the pen drive to store your data or delete your data. Okay, but at that time we are not having to delete our data. Okay, we are not having to delete our data, so we have to store our data permanently in the CDs, in the CD compact discs permanently. But to what is to copy and delete, if we required, we used floppy disk at that time. Floppy disk at that time. Uh, what is the memory capacity of this floppy disk? Anybody? Can you think how much it is? It is very, very, very less, 1.44 MB, 1.44 MB only. Okay. I will write here. Okay, so the memory capacity is 1.44 MB only. See how much less it is. See, actually, while I am doing my project at NIT Calicut, I used only for a few, only for a few files, I used the nearly 10 floppy disk, 10 floppy disk. That means it is having very less memory. Okay, in one floppy disk, maximum 5 files. I can store maximum 5 files. Okay, so to complete my project, I need so many files. So I purchased more than 10 floppy disk. Okay, but why? Because at that time we are not having the pen drives. We are not having the pen drives. We are having only CDs only we are having. Okay, CDs only we are having. And we are having the internet which is deadly low speed. So definitely we have to use this floppy disk, but virus will be virus will be what is infected this one. Okay, through this floppy disk, definitely our computers will be affected by the virus. Okay, that is the problem what we faced in my MTech in NIT Calicut. So this is the floppy disk. Nowadays, nobody is using the floppy disk. Okay, so inside, if you open this one, that means if you open this silver one, this is the silver color. This is a light silver one. It is silver color. Okay, so if you open this one, some magnetic tape will be there here. Okay, so magnetic tape will be there. If you open this one, just if you slide to the left side, if you slide to the left side, one magnetic tape will be there. Okay, in that magnetic tape, we are storing our data. We are storing our data. Okay, so, uh, okay. So that is the main memory and auxiliary memory. Okay, main memory. For example, the main memory example are RAM or ROM. Okay, RAM or ROM is the main memory, and auxiliary memory is like CDs or DVDs like that. Okay, these are auxiliary memory. These are auxiliary memory. Okay, so another type memory we are having, which is a cache memory. Cache memory. It is a very high speed memory which is used to increase the speed of processing. Okay, so it is a very high speed memory compared to uh, what is main memory or compared to auxiliary memory. The cache memory is having very high speed, and it is used to increase the speed of processing by making current programs and data, by making the current programs and data available to the CPU at a faster rate. Okay, when CPU performing any task at that time, the what is the data related to that task is available at the cache. Okay, so the data is available in the cache here. While CPU performing one task, the data related or the programs related to that particular task are in the cache memory, See here, CPU is a very fast device. Okay, CPU, that means processor, is a very fast device, but whereas the memory devices, whatever it is, primary, that is a main memory or auxiliary memory, it is having the low speed. Okay, low speed. So to get more speed of transformation, we use the cache memory. We use the cache memory. Okay. See, this is the memory hierarchy in a computer system. This is the memory hierarchy in a computer system. So here we are having, 1 minute, we are having the CPU. Okay, so this is the processor. Okay, we can call it as a processor. So between the processor and cache, a direct link will be there. So there is a direct data transfer. There is a direct data transfer from the CPU to the cache memory. And there is a direct transfer between the main memory and the CPU. But this way of accessing the data, this way of accessing or transferring the data is slow. Okay, is slow. That's why the CPU will take the data in this way. The CPU will takes the data or will give the data Okay, so the way of transmission through the cache memory is fast data transfer, But the data transfer between the main memory and the CPU is a slow one. It is a slow one. Okay, so that is why we used cache memory in between the main memory and the CPU, main memory and the CPU. Okay, see here, the magnetic tapes are magnetic disk, which are we are calling it as a auxiliary memory. The magnetic tapes and magnetic disk, which we are calling it as a auxiliary memory, is not a direct communication with the main direct communication with the main memory. Okay, so the IO processor will be the responsible, IO processor will be the responsible for the data transfer from the main memory to the auxiliary memory. Okay, so we are having the IO processors, some ICs we are having. So that ICs, which is used as a IO processor, are the responsible for the data transfer between the main memory and the auxiliary memory. Okay, so this auxiliary memory means here it is magnetic tapes or magnetic disks like CDs and DVDs. Okay, so main memory is nothing but it's a RAM or ROM. Okay, RAM or ROM here. Okay, so the memory hierarchy will be like this here. Sorry, yes. See, the data transfer between the CPU and the register memory is fast. Okay, so the data transfer between the register CPU is very fast, but the data transfer between the magnetic tapes and the CPU or the data transfer between the auxiliary memory to the CPU is very slow, very slow. Okay, suppose if you have you observed this one? Suppose if your system you are having uh, 1 GB file, 1 GB file in your D drive or I drive or J drive. Okay, so what is the time taken between to copy from J drive to the desktop? Okay, that is taken as a time one. Okay, time one. Okay, I will write here. I will write here. See, you can observe the data transfer. Okay, so the data transfer, if you observe, the first one from your desktop or the data transfer between desktop to whatever it is, D drive అనుకోండి. Okay, D drive. In the D drive, you will have 1 GB data. You will have 1 GB data. Okay, so this one I am taking as a data transfer time T1, and the second one I am taking. Okay, so the data transfer between the DVD, between the DVD and the desktop. Okay, see, I am moving my data present in the DVD and I am pasting it on the desktop. Okay, so this is T2, which is faster, and which will take less time. Which will take less time, T1 or T2? Yes, which will take less time? It is T1 or T2? Yes. Yes. T1 or T2 Nandi? Yes. Is it T1 or T2? Which is T1 is greater than T2 or T1 is less than T2? Have you observed this one? Have you observed? సింపుల్ అండి. ఒక డి డ్రైవ్లో మీ ఒక ఫైల్ ఉంది. ఓకే, జస్ట్ మీరు అది కాపీ పేస్ట్ చేస్తున్నారు. ఓకే,
Sir, unmute.
1 minute, please wait 1 minute. Okay, now tell me. I am copying the file from D to desktop T1. It is data, the time taken the time taken by the data transfer is T1. If I'm copying the file, 1 GB file from DVD to desktop, I'm taking the time as T2. Which one is less? Have you observed this one? Yes, anybody? Have you observed? This is a simple one I'm asking.
T1, sir.
Yes, T1 only, kada? T1, have you observed this one? Because that is the auxiliary memory. That means you have to take the data from what is other disk. That means other IO device. Okay, so definitely T1 will be less. Okay, so the time taken by the T2 is more. If T1 is less means it is having the fast, the data movement between D drive and the desktop will be the fast one. Okay, so that indicates the data transfer between the CPU and the register memory will be the fast compared to the data transfer between the CPU and the auxiliary memory. Auxiliary memory. Okay. Okay. See. Okay, I will explain in detail about memory hierarchy. So the memory hierarchy system, it consists of storage devices. Okay, so the memory hierarchy system, it consists of storage devices employed in computer system from slow but high capacity auxiliary memory to, to a relatively faster main memory. Okay, that means the auxiliary memory, the data transfer auxiliary memory is slow, but memory capacity will be more. The memory capacity will be more. Okay, it is compared to the main memory. Or or it is employed even smaller and faster cache memory. That means here the cache memory capacity will be less. Okay, the memory capacity of the cache will be less, but data transfer will be more. Data transfer, what is the speed is more. Okay, here you have to think to what is auxiliary memory, cache memory. Auxiliary memory size will be more, and but it is slow. But cache memory, the size is less, but it is more fast. Okay, slow magnetic tapes used to store removable files. Okay, that means just I have taken the example of floppy disk. Okay, floppy. So it is a magnetic tape device which is used to store removable files. Okay, so if I need that one, I will take the data from the floppy. Or if I don't want that file, just I will remove the file from my floppy. That is, it is nothing but it is a removable file. It is a removable file. So that is the magnetic tapes are used to it is used to store removable files. But magnetic disks are used as backup storage. Backup storage. See, for the backup storage, the floppy are not used. For the backup storage, the floppies are not used because the memory size will be less. Okay, for the floppy, okay, memory size will be less. Memory size will be less. That is why it is not used for the backup storage. Okay, are not used as a backup storage. Backup storage. Okay, so magnetic disks are used as a backup storage, not what is magnetic tapes. And main memory directly communication, it will communicate with the CPU and with the auxiliary memory devices through an IO processor. See, just now we have seen in the diagram here, this is the one. Okay, so CPU between the data transfer between the CPU and the main memory, we are having a direct data transfer, and between the main memory to auxiliary memory, there is no direct data transfer. We are having IO processor is here. We are having in between IO processor, which is what is it is the main responsible for the data transfer between the auxiliary memory. The main memory is what is IO processor. Okay. So the programs not in main memory, which are needed by the CPU, they are brought it from auxiliary memory. Okay. Suppose the CPU is executing the programs, the CPU is executing the programs. While executing, if the programs are not in the main memory, is not in the main memory, so definitely they are brought it from the auxiliary memory. Definitely we have to take the files from the auxiliary memory. Okay, why we are storing the programs in the auxiliary memory is to free up the space, the main memory. Okay, so to freeze the space for the what is main memory, we are using auxiliary memory to store our programs. Okay, to store our programs. Okay. And what is the cache memory? Cache memory is used to compensate for the speed differential between main memory access time and processor logic. See here, the processor is a very speed device, very high speed device, but the main memory is a low speed device, low speed device. But while data transfer is taking place between what is between the processor, that means CPU, and the main memory, okay, sometimes the processor will wait. Okay, the processor will wait. That means at that time the processor is in ideal state. The processor is in ideal state. Okay, so to overcome that one, we are using the cache memory. We are using the cache memory. For example, okay, 1 minute. I will show one, this one. ఒక్క నిమిషం ఉన్నారు. Okay. One minute, I will play the video here. Just animation. Actually, because of some network problem, so actually the data transfer from cache and CPU, it is coming very fast, but because of some delay in the teams, so you are not getting the what is animation clearly. Struck అయి వస్తుంది కదా. See, the data transfer between the RAM, that is the main memory, and the CPU, data transfer is less. Data transfer is less. Okay. so between that data transfer, the CPU will wait. Okay, this animation shows that means just it is a sleeping, just it is a sleeping. That indicates the data transfer between CPU and a RAM is very slow, very slow. Okay, and the data transfer between what is cache memory and the CPU is very high, very high. ఓకే ఐ థింక్ మీకు కనబడలేదు అనుకుంటాను ఓకే ఓకే ఐ థింక్ ఇది ఇట్ ఈస్ ద వీడియో వాస్ నాట్ విజిబుల్ సో ఫాస్ట్ because of some network issue. Okay, that means there is a network delay will be there. Okay, video fast transition, any videos it is not showing perfectly. Okay. Okay. That means CPU use faster than main memory. Okay, so with that result, the processing speed is limited by the speed of the main memory. Okay, that means if you are transferring the data from the main memory to CPU, okay, it is taking less time. It is taking more time. It is taking more time because CPU is very fast and main memory is very slow device, very slow device. Now you are doing the communication between very high speed device and low speed device. But automatically what will happen? The data transfer becomes low. The data transfer becomes low. Okay, so because of main memory. Okay, but to overcome that problem, that is a speed limitation, we used the what is cache memory. So small cache is inserted between the CPU and main memory. Okay, the small cache is inserted between the CPU and the main memory. So the data transfer will be fast. Okay, because cache is a very high speed device, very high speed memory device. Okay. And what cache is having? So it is used for storing segments of programs, not total program. Segments of programs currently being executed in the CPU. Okay, and the temporary data which is frequently asked by the CPU. Okay, frequently asked by the CPU. So the what is cache is having some segments of programs. That means the large program is divided into some segments. So it is having, the cache is having some segments of programs and the temporary data. Okay, which data it will store? The data that frequently asked by the CPU, it will store. The cache will store the temporary data that is frequently asked by the CPU. Okay, and here see what I told in the diagram means IO processor manages, or it is a responsible for the data transfer between auxiliary memory and a main memory, and at the same time the cache is also responsible for the transfer of information between the main memory and the CPU. Okay, the main memory and the CPU. Okay, so we have seen, if you see the cache memory and auxiliary memory, the storage capacity of the memory increases. Okay, the storage capacity of the memory increases, the cost per bit of storing binary information decreases. At the last, what will happen? The access time will be longer. Access time will be longer. Okay, that means what is the meaning of this one is the auxiliary, what is memory. Okay, the auxiliary memory is having what is a large memory capacity it is having, but the access speed is very less. Access speed is very less. Okay, so are you hearing what I'm telling? Any doubt? Any doubt?
Yes, sir.
No. Vaishnavi? Vaishnavi?
No doubt, sir.
No doubt. Next. Okay, action money. ఏంటి Kaparti is on hold. Prithviraj, Bhargav, Ismail Mirza, Vishnuvardhan, 7 members. Out of 23, only 7 members are boys. Remaining are girls only. What about Surya Prakash? Your strength is still decreasing. Surya Prakash.
Yes, sir.
ఏమే అబ్బాయిలందరూ ఆబ్సెంట్ అవుతున్నారు, అమ్మాయిలందరూ వస్తున్నారు, పర్లేదు. చూసుకో బాబు, చూసుకోను. That means if the storage capacity of the memory increases, if the storage capacity of the memory increases, access time will be more. That means the speed of access the data will be less. Okay, so for example here the auxiliary memory has a large storage capacity. Okay, auxiliary memory has a large storage capacity. Okay, but it is relatively inexpensive. Okay, relative to what is a main memory. Okay, and has a low access speed compared to the main memory. Okay, that means auxiliary memory, large storage capacity. Okay, but what is low access speed compared to the main memory? But it is inexpensive. చూసినారా మనకి ర్యామ్ అమౌంట్, ర్యామ్ ప్రైస్ ఎంత ఉంటుంది, జస్ట్ డివిడి ప్రైస్ ఎంత ఉంటుంది చూసుకోండి. ఓకే, సో 1 GB ర్యామ్ size, 1 GB RAM size, and what is DVDs, what is 1 GB RAM cost, 1 GB RAM cost, and 1 GB what is DVD. I think more than 1 GB. I think it is of around 4. I think 4 ena babu DVD size. Enta size of DVD? Yes. Yes, size of DVD how much? Yes. What is the size of DVD disc? 4.7 GB. Yes. 4.7 GB. Okay, of course take 4.7 GB DVD drive and 4 GB RAM. ఏది అండి కాస్ట్ ఎక్కువ ఉంటుంది? Yes. Which is having more cost? Nobody is answering.
DVD.
Yes.
DVD.
More cost, Babu. Selina, can you tell the answer? Okay, so 4 GB, I think 4.5 GB DVD I will take, 4 GB RAM I will take, 4 GB RAM I will take. The which cost is more? Which cost is more?
4 GB RAM.
Yes, 4 GB RAM the cost is more. Okay, So, so auxiliary memory has a larger storage capacity compared to main memory, But to access the data from the RAM, it is less time. But to access the data from the what is DVD, it will take more time. It will take more time. And the cache memory is a very small memory, but relatively it is expensive. Relatively it is expensive and high access speed. It is having high access speed. Okay. Now, memory access speed is increases. Okay. The cost is also increases. Of course, the memory access speed is increases, accessed by the CPU. If it is increases, of course, it is proportional to the cost. Cost is also increases. Then, what is the main aim of memory hierarchy? So it is to obtain the highest possible average access speed, while minimizing the total cost of entire memory system. Okay, see, in some circuits, in the some circuits, it will need very high speed of data transfer. In some parts of the computer, we need a very high speed data transmission, very high speed data transfer. In some, in what is in some area in the system here, it does not depend on the speed. Okay, if it is less, that's no problem. Okay, so whenever you need the fast device, you have to use that device in that part. Okay, whenever the size is important compared to the what is speed, compared to the access speed, if you what is memory size is important, you have to use the more memory device there. Okay, that means overall the efficiency of the memory system has to increase with the minimum cost, Okay, so మనకు కొన్ని సర్క్యూట్స్ లో ద స్పీడ్ అనేది కావాలి ఉంటుంది, కొన్ని టైంలో కొన్ని పార్ట్స్ లో ద స్పీడ్ ఈస్ డజంట్ మ్యాటర్. ఓకే, and CPU has direct access to both cache and main memory. Of course, it is not with auxiliary memory, but the access with auxiliary memory is done through the IO processor. Okay, so the data transfer from auxiliary to main memory is usually done by means of direct memory access of large blocks of data. Have you heard about DMA? Have you heard about DMA data transfer? DMA. It is one type of data transfer. Okay, direct memory access. Okay, direct memory access. This is one type of data transfer. Okay, so actually how it will take place means here some some device, some IO device will be there here. Okay, some IO device, and it is a processor, and it is a main memory. Okay, and it is a main memory. Okay, so auxiliary memory, we are taking it as it is acting as an IO device here, and main memory. So the data transfer between IO and main memory is done by this processor, by using the technique direct memory access technique. Okay, that means what is happening here means So okay, ఇది చిన్న రస్. Okay, this is a microprocessor అనుకోండి. Okay, and this is the uh, auxiliary memory. This is the auxiliary memory, and this is the main memory. This is the main memory. Just process, just processor initiates the data transfer between auxiliary memory and main memory. That's it. But the total transfer will takes place directly. Directly the data transfer will takes place. Just what is the purpose of using this processor means just it initiates the data transfer. Okay, then using the system bus the total what is data transfer will be takes place, that is direct memory access. That means this will be accessed directly with the main memory. That means it is used when large blocks of data, if you want to transfer large blocks of data, we will use this technique, DMA technique. Just what is the purpose of this processor? Just it will initiate the data transfer. After that, the data transfer will be taken place by the bus here. Okay, so direct access of the memory is possible. Okay, and the part of computer system, 1 minute. Okay, so the part of computer system that supervises the flow of information between auxiliary memory and main memory is called a memory management system. Okay, the part what we are what is supervising, or it is a responsible for the data transfer, that part we are calling it as a memory management system. Okay, in this the processor is the processor part of what we are calling it as a memory management system. Okay, and at last, what is multi-programming? Multi-programming. So it is the existence of two or more programs in different parts of memory hierarchy at the same time. Okay. Uh, so when main memory is performing, or it is doing the data transfer multiple times at the same time, simultaneously. Okay, so that programs are called multi-programming. Okay, so suppose if you are taking the data transfer between CPU and the auxiliary device, okay, that means auxiliary memory. Okay, of course it is very slow. Of course it is very slow. But the data transfer is going on. The data transfer is going on. That means one program is running. One program is running. That program indicate the data transfer between the CPU and auxiliary memory. But at the same time, the CPU is performing some other task by executing some other programs. Okay, the CPU will execute some other programs at the same time while what is the data transfer while taking place. So what CPU is doing? CPU executing multi-programs. CPU what is executing multi-programs. Okay, so this is the one what is small point here. What is multi-programming means? At the same time, okay, the simultaneously the processor is execute more than one programs is called multi-programs. So with this one, multi-programming has any advantage here or disadvantage? Advantage or disadvantage only having multi-programming technique? Yes.
Advantage.
Yes, advantage. Advantage only because the speed will be increased. The speed will be increased here. Okay, as in the case of what is 8086 processor. See, 8086 processor, if you observe the block diagram, the totality is divided into two blocks. execution unit, and what is another one is control unit. Sorry, bus interface unit, execution unit and bus interface unit. That means when a processor is executing the current instruction, when processor is executing the current instruction, at the same time the processor will fetch us the opcode of next instruction, the opcode of next instruction. Okay, so that is multi-program, that is parallelly the CPU is performing multiple task. Okay, so this is about multi-programming, and this is about memory hierarchy. Okay, memory hierarchy. Okay. Yes. Okay. So in the memory hierarchy, we are having main memory, cache memory, CPU, IO processor, magnetic tapes or magnetic disk. That is the data transfer between main memory to auxiliary memory, or CPU to main memory, or CPU to cache memory. Okay. So this is the first topic, what is about memory hierarchy in a computer system. Okay. So any doubt, please ask the doubt. No doubt. Hema,
Yes, sir.
Hema. Any doubt, ma?
No, sir.
No. Nagasai Srinivas. Nagasai Srinivas. Nagasai Srinivas. Ritvika. Ritvika.
Yes, sir.
Any doubt, ma, in this case?
Sir, is cache memory exists in our phone also, sir?
Yes, definitely. Definitely.
Okay.
Okay, definitely. Yes. And what about Bhargav?
No doubt, sir.
No doubt. Okay. Okay, ma. Fine. So